Hi everyone, let's solve this problem. Meeting rooms 3. You are given an integer n. There are n rooms numbered from 0 to n minus 1. Let's say for example n is equals to 2. That means there will be two rooms 0 and 1. You are given a 2D integer array meetings where meetings of I is equals to start of I, end of I. Means that a meeting will be held during the half closed time interval start and end. All the values of start are unique. And let's also understand the half closed interval. A comma b is the interval between a and b, including a, not including b. Let's say for example this is the case. Then if the meeting is from 0 to 10, the meeting will happen only from 0 to 9. So the next meeting, if it starts from 10, can also book if it is ending at 10. That's what at 10 time they can book it. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. So if there are like multiple rooms available, the room with the lowest number will get the preference. If there are no rooms available, the meeting will be delayed until room becomes free. The delayed meeting should have the same duration as the original meeting. Let's say for example this meeting is being delayed and it gets the room at 10. Okay, instead of 1 it gets the room at 10, so it will start at 10, but the duration of the meeting is 5 minus 1, right? So it will go till 10 plus 5 minus 1. So the start is 10, end is 14. So that's what they are mentioning. When a room becomes unused, meetings that have an earlier original start time should be given the room. If there are multiple rooms and if there are multiple meetings, the meeting which has the minimum start time will get the preference. So for the same reason we have to sort our meetings with the start time so that this particular thing is always satisfied. Return the number of the room that held the most meetings. If there are multiple rooms, return the room with the lowest number. So every meeting room will have a number of meetings booked, and if we should return the room number which has the maximum number of meetings booked, and if it has multiple of them, we should return the room number with the lowest number. So that is what should happen. So now let's try to solve this. Let's take this particular example itself. We need count. We'll maintain an array. Initially all of them will be 0, and we have available rooms. Available rooms will be 0 and 1 in this case because there are two rooms. We also have to track occupied rooms. Now we have to iterate over. Before iterating we have to sort these meetings based on the start times, but in this case it's already sorted, so we don't have to do anything. So we'll iterate over every meeting now. We will see available rooms. Room 0 is available. We'll take it. We will book the room 0 and we'll add the end time. We need this end time to know if the meeting is done or not, right? For this purpose we will need end time. So, and also I'll increment the count 1, and then we'll move to the next meeting. There is a room available, so end time is 5 and we book the room 1. So this is nothing but end time comma room number. So this is what it is representing. Now at 2, like start time 2 and end is 7. At 2, if you see, there are two meetings going on in both the rooms. Until 5 we will not get a meeting room, so this particular meeting will get delayed and it will start at 5. So if it is starting at 5, its end time will be 5 plus 7 minus 2, right? 5 plus 7 minus 2 will be 5. It will be 10. This will be the updated meeting times for this particular meeting. Now at 5 this will get free. Okay, we also have to increment this one. At 5 this meeting room will get free, so room 1 is available. When it is available, the meeting end time with the updated delay is 10 comma, and we are booking room 1, and we are booking room 1, so I have incremented the count here. So again we'll move to the next meeting. At this particular meeting, we see that at 3 there are no rooms available, right? And we have to wait till 10, and both the meetings will be over at 10, but we will always pick the least number available, so we consider this. So the meeting which has to start at 3 is starting at 10, right? If the start time is 10, the end time will be 10 plus the difference between the end and start. So the updated timings will be 10 and 11 for this. At 10, this particular will become available, room 0 is available. So what am I going to do? I'm going to insert the end time, updated end time 11 and the room 0. So 0 is also booked, and we'll also increment the count. If you see, towards the end of all the meetings which are done, the number of bookings done here are, for 0 room it is 2, for room 1 also it is 2. So we are going to just return 0 because it has the lowest number. Let's say for example I have 10, 29, 30, 59, 60, 79. These are my meetings. Okay, let's say for example my available rooms are 0 and 1. My occupied is, I have taken room 0, so let's say end time is 29 and the room is 0. So now when I am here, what should happen? Should I book room number 1 because it is available, or should I free it because the end time, this is the end time, right? End time is less than the start time of the next meeting. These rooms should be freed up before that, right? So we also have to handle this use case. And whenever we kind of waiting in the code, we are not actually waiting, we will just see the top of the minimum heap in this particular occupied min heap, and then we'll just calculate our delayed start and end. We don't really have to calculate start because we are not storing anywhere, but end delayed time is required. And why are we using the heap here is that to always get the minimum room available in the available, and for the occupied it is always minimum time, end time, and if minimum end times are equal, it will again give us the based on minimum room number. So now let's write the code for the same. We have meetings, so we are going to sort the meetings to ensure this property is being satisfied, right, which we discussed. So I'm going to sort them, and meetings has start and end, so we are going to ensure that it is sorted based on the first value start time. Then we are going to declare available min heap. Again we have to use the property a minus p here, and available will have only just room numbers, so this is fine. And then occupied, it will again be a min heap, but here we have to check couple of things. If their end times are equal, we are going to depend on the room numbers, else we are going to depend on their end times itself. Then we also have a count array, so it will not be nothing but it will be of size n, and initially all the values will be 0, and we have to ensure that we add all the rooms to available heap. Okay, then we have, for every meeting we have start and end. We are going to iterate over all the meetings. Like we discussed, initially we have to empty rooms of the previous meeting if there are any. So we will check if occupied has any elements or meetings. If yes, we are going to check its front of 0. Front of 0 is nothing but the end time. It is less than or equal to start. Then we are going to just remove that. So occupied dot dq. So we are going to free that room. After freeing, we have to enqueue it into the available dot enqueue. Enqueue will be the room, and then we will have a delayed end. Generally it will be just end. If there are no rooms available dot is empty. In that case, what are we going to do? We are going to free the rooms. How are we going to free the rooms? By getting the occupied rooms. So occupied dot tq. So once we kind of get the end time and room, that means delayed end can be calculated end time plus end minus start, right? And available dot enqueue of room. So since there was no room available, we are making it available. That is all we are doing here. Once this is done, what will happen? We know that we have to occupied dot enqueue, we have to add the delayed end comma room. And how are we going to get the room? We are going to get the room from available dot dq. And once we get it, we have booked it, and then we are going to increment the count of room to this. Okay, after this, answer room equal to 0. We are going to iterate from 1 since we have taken the room as 0 already. And basically in this case, we are just finding the room with maximum bookings, and then we are just storing the index. So if count of answer room is less than count of I, that means I have a better answer in I. So the room will be updated to I, and then we will be returning answer room from here. So yes, let's try to run this up. Okay, seems like there is a okay, I made a mistake here with this. Let's try to run it. Okay, let's understand this. So we are sorting our meetings. We have available min-heap. Then we also have occupied. If both the end times are equal, we are depending on the rooms. If not, we are just depending on the end times. And then we have a count which is filled with 0, and we are making available have all the room numbers. Then we are iterating over all the meetings, and if it is not occupied, we are kind of dequeuing the occupied and then ensuring that it is being part of available. And then we have a delayed end. Okay, delayed end is here. So delayed end, this was a spelling mistake here. Delayed end is equals to end time plus end minus 1. So this should run. Okay, let's submit it. Right. So now let's also understand the time and space complexity of this. So basically, let's consider the number of meetings is m, and n is already given as rooms as n, right? So what are we doing here? For meetings, we are sorting it. So if we are sorting m meetings, m log m, right? And then we have declared heaps. So this will go under space. Space complexity is n plus n plus n. So basically we are having available, occupied, and also count of sizes n. So it will be n for all of them. And then this is again n time, and then we are kind of iterating over all the meetings, and either we are inserting into the occupied or we are getting it from the available, this entire part. So it is nothing but n, there are m meetings, and every operation is log n for heap, either getting it or deleting it. So it will be m log m, and then we have this iteration n. And for the space, we have also used sorting will take some space m. So overall the time complexity is m log m plus m log n, and the space is n plus m, big O, right? These are the time and space complexities for this problem. I hope the solution is clear. Thank you.